Up to this point, I have been talking about the private 5G, right? How simple we can make it, integrate cleanly into enterprise. The next practical question we usually get is, how do you actually connect all these different type of enterprise devices, industrial devices? For mobile cellular devices, the story is straightforward. As you see here, the rugged tablets and scanners and push-to-talk devices already support SIM-based connectivity, and they attach directly to private 5G today. Where it gets more interesting is everything else. In real industrial environments, you rarely have only single device class, right? You have AGVs, robots, devices that only support maybe Wi-Fi, legacy industrial equipment that speaks serial or fieldbus protocols, and sensors that use technologies like wireless HART or LoRaWAN. The question is, how do you bring all these devices, legacy devices, into the same operational system without forcing total replacement of these devices? And the answer is really gateways. We use industrial-grade gateways to act as protocol and access bridges between the legacy and or non-cellular devices to private 5G. These gateways connect upstream traffic into private 5G and downstream using whatever interface devices support. So you can have Wi-Fi or Ethernet or serial or fieldbus or even low-power wireless protocols. Depending on the environment and use case, we see different gateway form factors, everything from mobile routers mounted on AGVs to fixed industrial-grade factory floor gateways. From the network's point of view, all of these devices, whether they are natively cellular or connected through a gateway, become part of the 5G. So inherently, the same IP addressing, security policies, visibility, operational controls extend. This approach allows customers to incrementally modernize their network so they can bring the private 5G into their environment today and connect existing assets, then gradually introduce more cellular native devices over time, or they use these IoT gateways without fragmenting the network in terms of the operational model. Now, once you start connecting these devices through gateways, the next challenge becomes how specifically in this environment, industrial environments, what happens to the devices behind the gateways? We have full visibility, right? Many of these devices are not even IP native, right? And they may be relying on layer 2 industrial protocols such as PROFINET, EtherCAT, Ethernet IP, Modbus, TCP, Profibus, all of those. In many cases, the PLCs and controllers on both ends expect to be on the same L2 domain, layer 2 domain. So that's where the traditional approach starts breaking down, and there is some ongoing work in 3GPP to support these use cases. But what we have seen is a demand for this, and as Celona, we support all of these kind of layer 2 use cases through layer 2 tunneling over the private 5G network using these mechanisms like GRE and VXLAN. So we essentially carry the layer 2 Ethernet frames encapsulated in layer 3 packets, because 5G is inherently a 5G layer 3 technology, but with the tunneling, we're able to carry these layer 3 Ethernet frames in this layer 3 network. In this architecture, the gateway near the industrial device encapsulates the traffic and sends it over the secure tunnel over private 5G, and on the other end, Celona Edge terminates that tunnel and presents the traffic into the enterprise network. And from the perspective of PLCs and controllers, nothing changes. Both ends of the PLCs on both sides, they still see a trusted transport layer. This is particularly powerful for mobile use cases like AGVs with integrated gateways, where you need to preserve this deterministic control behavior while allowing the endpoints to move freely. And because this runs over private 5G, we can combine it with microslicing and QoS enforcement and ensure that all the prioritization and quality of requirements are met. The key point here is that we are not forcing OT systems to adapt to cellular. We are really adapting the cellular network to the realities of the industrial IoT system.